Alright, so go ahead and go over your homework. You're looking over it, over how to name binary molecules while I check your homework. It's taking forever to load. Hope it's going. Where are you not
Every other
over
class
there?
we're like page
Are we
17.
behind?
For, what do you mean?
Or, well, you have to think, the chemistry book is that big.
Yeah, no, yeah, I know.
Right,
It's one of
right,
those
small.
to where like the chemistry book, it'll jump forward and then it'll keep, and it'll
So
slow down.
It's like algebra.
Yeah, so it's one of
So-
those, don't worry about the book, oh, I'm only on those pages. No,
Are we
don't worry about
behind?
it, we'll catch up.
Are we behind?
We're fine. Alright. Alright, so for your homework, it was on page number 42. You were supposed to practice having naming these different ionic compounds. Now remember, do you use prefixes with ionic compounds, Ethan?
No.
Nope, you don't. We're just naming just the cation and just the anion, and then making sure they have the number of proper electrons. Alright, does anyone want to go first? Alright, Ethan. So what do you got for that first one? NaNO2.
Sodium nitrate.
That's it. Alright. AgNO3. Alright, did you say sodium nitrate or sodium nitrite?
Nitrite.
That's it. Just making sure. I just want to. So you do
I
have
did that.
NaNO2?
But I wrote it down.
You
what?
don't- you don't-
I
Okay, because one year the book printed out and something else one year. So I always have to check to make sure that they have dialed one properly for it. Alright.
Because at first I wrote nitrate because it was like right under the other one.
Mm-hmm.
And then I changed it.
Good job, you figured it out. Alright, so AgNO3. Alright.
I had argon trinobilide, but I know that's wrong now, so
Okay.
it's argon nitrate.
Alright, is Ag, is that argon?
I think so.
Yep.
What is it?
Silver.
So, alright, silver nitrate.
Nitrate. So again, remember this is naming ionic compounds. So let's see, okay, is this a binary molecule or is it an ionic compound? That's why you want to slow down whenever you're doing your homework and make sure, what am I looking at?
I got
Because
three right.
Well, that's good. Well, I just want to make sure on quizzes that you don't fly through it too fast, and then on the test as well, you're not flying through it too quick to where you're losing points because you know what you're doing. You're just not going. You're just going too fast. So slow down and just figure out what am I doing. All right, letter C, Ethan. What is that? CuCl.
It's not copper chloride, is it?
It is copper chloride, but is there more than one version of copper?
Copper 3 chloride?
Why?
Copper 2
Why
chloride?
copper 3?
Copper 2 chloride.
Why?
Because that's the number of, it can be more, it can have more than one.
You can have more than one, but you don't just call it 2 just because it has more than one. So, all right. So how many electrons does chlorine typically take?
One.
All right. How many is copper lost then?
Do what?
How many is copper lost then?
One.
1. So whenever you're signing the Roman numeral, what does the Roman numeral tell you?
So wait,
What is it? The charge, yeah.
Charge. All right. So this would be if it has a positive 1 charge, it would be
Negative. Wait, positive. Wait, what?
okay. So it's lost 1 electron. So what's its positive charge?
1.
All right. So it would be copper
1.
1 chloride. So that's the full name for it.
So
And yeah, you do have to have the Roman numeral in parentheses.
copper
in the name.
chloride could be wrong.
Yeah, technically, because there's 2 different versions of copper, so you have to know. That's why I said there's
Why?
5 of them. Because scientists, because if you say copper chloride, the scientists don't know. The scientists don't know which one is it. Is it the one that's lost 1 electron, or the one that's lost 2? They act entirely different. So just because it's copper doesn't mean it's going to do the same thing every single time. So scientists want to know. So whenever they say copper 1 or copper 2, they're saying which one it is. All right. So the next one, PbSO4. Okay.
Lead sulfate.
Good job. Now, is there more than one version of lead?
There is.
There it is. Okay.
So it's lead 1 sulfate.
How do you know?
It is. Because, oh no, there's 2, so it's lead 2 sulfate.
There you go. That's it. So sulfate, you'll have to memorize, which again for the charges, that sulfate that has a negative 2 charge, so that means the lead must have lost 2. So that's why it's lead 2 sulfate. Okay, you got it?
I think so.
Okay, good.
Can
Alright.
we do more later?
We can go. Actually, we can go ahead. We can go ahead and practice
Like
that.
do
So
one more,
look at, if you open up your book and look on page 42, let's do E and F because these were not part of your homework. So not part of your homework. Let's just practice with them really quick. All right. So this one's a little bit trickier. So what is the Zn? Anyone remember what that one is?
Zinc.
Okay, that's zinc. And then what is PO4?
Oxygen and
PO4.
Phosphate.
That's phosphate. Alright, so is there more than one version of zinc?
No,
No, there's not. So what's just the name?
zinc.
Zinc phosphate. So that's just the name just for that one. You don't have to worry about it if there's only one version. So don't get hung up on, okay, what's the charges for it? Okay, for this one, it's already balanced out for you, so just name it. Alright, letter F. A little bit trickier because there's so many atoms all shoved up together. So the NH4, that's the cation section. So what is this? You're gonna have to just memorize this one.
Ammonium.
Ammonium, and then what is the C2H3O2? Remember what that one is, Chris? Or can you find it real quick?
Acetate.
That's it. So this one would just be what, Chris?
I don't remember what NH is. Ammonium.
There you go.
Acetate.
That's it. Alright. So we'll practice hopefully a little bit more later on. Does
I
anyone have a
think I got
question?
it now.
I think it's in one of those. Once you get it, it's one of those.
Because,
Okay. I get it. So this is ionic compounds. This is how you name an ionic compound.
On the table, it says copper, like there's copper 1 and copper 2, copper 2, it says, Cu2 plus, so
Mhm.
charge 2, that's.
Yeah, charge 2.
Charge 2, copper 2.
Yep. So that's one of those. Once you get it, you got it. It's one of those just finding it and just connecting that. It's a little bit hard because your book hasn't talked about the valence electrons yet, but there's no right or wrong way to teach chemistry. Whenever I learned chemistry, we learned about valence electrons first. So it just depends on what section you want to start with. There's no right or wrong way because all of it loops back together. So eventually you'll learn all of it. That's the reason why I keep talking about valence electrons, because to me it makes more sense to talk about that way. You can just memorize it, and that also works. Alright, let's look at the letter 2 now. Write the formulas for the ionic compounds from each of the following pairs. This one's a little bit trickier because they're making you actually put them together and balance out the electrons. Anyone want to go first? Alright, Chris, what you got?
NaSO4.
NaSO4. Alright, is that it?
That's what I have.
Alright, what is the charge of the SO4? Because you gotta balance out the number of electrons. You can't have electrons just pooping in and out of existence. They gotta go in somewhere.
It's Na2SO4.
Good job. Now you fixed it. Why'd you fix it?
Because I saw that SO has a negative charge.
Yep, so this whole anion section has a negative 2 charge, and you're right that sodium, it can only lose 1. So you have to have 2 sodiums to balance that one out. So that's why it's N2SO4. So good job figuring it out that way. Alright, so the next one, PB4 and PO4 with a negative 3 charge. We're making you balance out this lead and the phosphate ions. Alright, Ethan.
Is it, PB3, PO4?
PO4. Alright, you're super close. Alright, how many of these PO4s do I need to balance out the fact that there's 3 of these?
1.
Alright, well, what's the charge of 1?
What's the charge?
Oh yeah, because this lead is positive 4. So it's throwing 4 electrons off for each one. So you're right, you need 3. But I need to balance out the charges. So this.
So 3, PO3?
Yep. Nope, close.
Oh, negative 3 charge?
This one has a negative 3 charge. So this one has 3 of them, but they're throwing off 4 electrons each time. So how many electrons total has the cation section thrown off? If there's 3 leads and each time they're throwing off 4.
12.
12. So that means I've lost 12 electrons total for the cation side. So that means I have to have the anion side take the 12 electrons. But each of these phosphate can only take 3 at a time. So 3 goes into 12.
3 goes to 4.
4. So I need 4 of them. So that way each one will take 3, the next one will take 3, the next one will take 3, the next one will take 3. So my number of electrons balances out. So that way the anion side has now taken the 3 electrons. Alright, does that make sense for you?
Getting there.
It's getting there. You can't just have electrons just thrown away into nothingness, because electrons are physical substance. You can't just throw them away and say, oh, they don't matter anymore. They have to be going somewhere in this compound. Okay. Okay, let's practice some more with C and D, even though these are not part of your homework. Well, let's go practice with them. So, iron 3 ion. So what's it telling you if it has the 3 in parentheses? What does that mean?
It has 3 iron. 3, it has more than 1.
Okay, remember it's not
With a
prefixes.
positive 3 charge?
There you go. So yes, it's lost 3 electrons. So this is iron, which hopefully you remember it's Fe. So it's positive 3 to where it's lost 3 electrons, and then chloride ion. Alright,
Oh, you got it.
chlorine, what?
Is Is it, I see that.
I'm sorry, okay.
Is it, iron 3, chloride 3?
Okay, so, whenever you're naming them, you say iron.
Iron, Roman numerals 3, and chloride 3.
So, this one you have a 3 Roman numeral 2,
Yeah,
or you're
because
talking
it
about the
only-
subscript?
Subscript, because it only gives off a negative 1 charge.
Yes. Alright, now, whenever you're writing them out like this for the formula, you don't have to write the numeral. You only write the numeral if you're naming them in words. So, if you were to write iron, like iron 3 like that, and then chlorine, that's how you include Roman numeral. But you don't write like a Roman numeral just for the substance. Alright, does that make sense, Ethan, how we got 3 chlorines?
Because the iron was giving off here.
Yep. So, in each chlorine, you
And I
only
only
take
have
one.
So
So,
I
we have,
three.
yep.
Alright,
So
I
finish
think
it,
I
got
got it, I don't know, can I do the next one?
Sure. Alright, so what is K as a side note?
Potassium.
Good job. Alright, so we have potassium. How many electrons is it giving off?
1.
Alright, now what is, that's dichromate as a side note. So Cr2O7, and it tells you what the charge of it is. So it's 2 negative. So potassium can only give off 1, but each of these dichromates can take 2. So how many potassiums do I need? 2, and that's it. You don't have to put it in parentheses. Technically, you're not supposed to. I'm just helping you just to see this is the whole anion right now. Alright, anyone have any questions about number 2?
I don't know.
We'll practice. Alright, number 3, write the formulas for the following ionic compounds. So you had A and B.
I got it.
You got it?
Yeah, Ca3, P2.
Good job. So Ca3 and then P2. Alright, why?
Because the P, which is phosphorus, gives off a negative 3 charge, and the calcium gives off a positive 2 charge. And to make them balance out, you would need to bring to the lowest common multiple, which is 6.
Yep.
So, yeah.
Perfect. But yeah, so this is for this one. Alright, Ethan, you got any questions about that one? Alright, let's do the next one. Potassium sulfide. Alright, so potassium.
K,
Yep.
K2S2.
Super close, but not
That's
close.
what's, is it, the 2, is it 2 negative?
Alright, so sulfur takes how many electrons on the chart?
2.
Negative 2. So, how many electrons does potassium lose?
Add 1.
Yep, just 1. So, if sulfur is taking 2 each time, how many potassiums do I need to balance that out?
2.
2. So, just make a note that if it gives you the charge, you don't want to write the charge down here.
That's what I was thinking though, when I put the 2.
Yeah,
I
so,
was thinking it was in the end.
yeah, you always put the charges up on the top right side, and we put the subscripts telling you the number at the bottom. So just be careful for that. Alright, let's do number D.
Sulfate is this.
Wait.
K2S?
Yep, that's it.
No,
Because
sulfate is SO.
Sulfate. I thought this was
sulfide.
sulfide.
Sulfide. Remember, you take the ending and it changes into the anion for it. So you all write the sulfate though is SO4. But yeah, so just be careful. Just be careful. Alright, letter C. Lead 4 chromate. Okay, so if it's lead 4, how many electrons has it yeeted off? Alright, Chris?
Chromate. So it's gonna be Fe.
Alright, remember this is lead.
Lead. Oh, okay, sorry, let me see.
Alright, if it's lead 4, Ethan, what does that mean? What's it telling you with Roman number 4? What?
PB4.
Good job. So, I wrote B first there.
So it's PB4, CRO2.
O4. And then how many of them did you say? 2. Yeah, because this one has a negative 2, but this lead is throwing off 4 every single time. So because of that, I need 2 of them to
So
balance
was
it out.
You have to parentheses in that one or something?
For this one, yes, because I'm saying I need 2 of this whole anion. If I were to just leave it, leave it like this, it looks weird. It looks like I'm trying to say that there's 42 oxygens or that there's 2 of the O4s. So the scientists making decisions, they say, okay, put the whole thing in parentheses, I need 2 of these whole ions. So
Can we
two
go over that one
chromates.
again?
Can I do D?
Wait, what, so let me answer Ethan's question first.
Can we
Alright.
go over that one again?
Alright, so lead 4, what's the 4 telling you?
There's 4 lead,
Nope.
4 charge.
Yeah, so this lead is chunking off 4 electrons every single time. 4, 4, 4 for this particular one. Chromate, this one can only take 2 electrons at a time. So it can only take 2
So
and then it's
2 goes
satisfied.
into 4 two times, so the chromate, is that chromate right?
Yeah, this is chromate.
2, you need 2 sets of it?
Yep, so that way I have one chromate take 2, and then I have another chromate take 2, and now my number of electrons is
There's
balanced
no
out.
number for, lead just stays lead.
Yeah,
Lead.
it just stays lead. Now, if you want to write the charge at the top, you can, but that's just what signs are saying whenever they're saying lead 4, they're telling you that this lead had this particular one's lost 4 electrons. Alright, let's give Ethan practice with this one, and then I'll come to you, Chris, if Ethan gets stuck to
So
her.
that's it there, okay.
Alright, so sodium and then hydrogen phosphate. So the sodium's the cation one, this one is a tricky one. So sodium is the cation section. So sodium loses how many electrons?
1.
1, so turn out positive. Alright, so hydrogen phosphate, that one has a funkier name, but this is what it looks like. Alright, so find that one and then see how many electrons can it take.
-3. 3 negative. What?
Check
Oh,
this
for
one.
sodium.
Alright, so
Sodium's 1, right?
sodium 1, okay, check this one's charge again, because it shouldn't be -3. HPO4.
4. 4, and then there's a 3 negative
Let me find it in your
for
charge.
phosphate.
No, oh, you're combining them. No,
Hydrogen
find,
phosphate?
yeah, find
2.
hydrogen phosphate. There you go. So, -2, this whole anion altogether takes
So
2.
is it NaHPO with parentheses, or HPO4 with parentheses 2?
Like this?
Mm-hmm.
Alright, well how many electrons has this one totally taken then? Because each of these anions can take 2. So how many total electrons are taken onto the anion side?
1?
Alright, so I have
Right.
one anion that takes 2, and then I have another one that takes 2. So
So
how
4.
many? 4?
4.
4. Alright, now why are you putting it in parentheses? Why are you giving more than 1? Because sodium only loses how many per time?
1.
1. So sometimes you want to find the least common multiple, so it's easier, so you can reduce your ion compound down as small as possible. So if this one only needs 2 to be happy, but sodium is throwing off 1 at a time.
Na4? Is it Na4? Or +4 or something like that?
Alright, so why are you going to 4? Because this one only
Well,
needs 2. This one only has 1. What's this coming?
Na2?
Yes. So you want to go to
HPO4?
yes. So for this one, you just want to go with the least common multiple. So this one, since each one only loses 1, so I can develop an entire positive 2 charge that'll balance out the entire negative 2 charge. So that's what I'm going to look for, the least common multiple. I'm not sure why you're trying to go up to 4.
Well, I was confused because on the other ones we did, I don't know.
It's okay. It just takes practice. Just look for the.
Up with something, other things.
It's okay. Just look
Why did
for the least common multiple. So you would have balanced it, but you were going too high for it. So again, you would have lost points just for not having the least common multiple. But you have the right idea. You want to make sure that your electrons balance. Okay.
Okay, I was about to say, I think his thought process was if you had the HPO4 and you had a 2, it'd be giving off a -4 charge. And then he did Na4 because it would give it a positive.
Yeah. Now that's part of the reason is how come you want to memorize your entire anion.
I think
This
it's
is an entire anion that has an entire charge of -2 altogether. So that's how come you want to memorize what the different charges are. Don't try to figure out okay what's P, what's O, what's H. No. Memorize your entire anion, memorize your entire charge. It'll help you save you time. You are going to start doing stuff like that later, but right now, no, just memorize this, just for right now. Alright, so we have any questions about that? Alright, we got to review really quick. Alright, so we have to move kind of quick, so we'll just do the dice game again, just so that I can move fairly fast for this section. I let Chris pick first yesterday, so I'll let Ethan pick first. Okay.
pretty sure we always pick the same dice.
Yeah, I think you all have favorite colors. Alright, so thinking back over it, what is the symbolic representation that specifies the elements present in a compound and state the relative numbers of atoms in each element? So what do we call stuff like this? I think we started with Ethan last time, so I'll start with Chris.
Start with that.
Yeah, technically starts with C if you're given like the full name for it, but I'll take F1.
Formula.
Formula or chemical formula. Alright, what is the name for the science where we're studying the numerical relationships between elements and the compounds?
Stoichiometry.
Stoichiometry. Alright, there are 3 basic types of formulas. What type of formula do we use for a molecule? So not these, because these are ions.
Start with an M.
Yep,
Molecular.
molecular formula. What is the type of formula that's used for something like an ionic compound where it's the simplest ratio? I'll take either name for it.
Start with an I, E,
E.
empirical formula.
Empirical formula, also known as the formula unit, but empirical formula shows the smallest unit,
Oh.
smallest one.
What was the definition on that again?
It shows the simplest ratio. So since these are ions, here's the simplest ratio for this substance.
That's an empirical
Is
formula.
empirical formula. We don't really use it with molecules because there can be more than one type for it. So most of the time we use these with ionic compounds. Alright, what means 10?
It means 10.
Yeah, like what's the prefix that means 10?
Start with an N. Or start with.
Ooh, it starts with D. It's making me nervous now. What's the
I
prefix
know,
that?
you just caught me off guard.
Sorry.
Deca.
Deca? Alright, what? I'm going out of order just to check to make sure. What means 3?
Try.
Good job. What means 9?
Nano.
Nana? What means 6?
Hexa.
Hexa. Sorry, hexa. What means 7?
Hepta.
Is it? What means 1?
Mono.
Good job. What means 2?
Di.
Is it? What means 5?
What start with?
P.
Penta.
Penta. What means 7?
Hepta.
Whoops, say again.
Hepta.
Hepta. Alright, what means 8? I think that's the last. Nope, what means 2? I skipped that one.
I have that one.
You got 2? I'm sorry. Alright, what
What
means
is
8
it again?
Di.
2 is die. Alright, what means 8?
8 is
There you go.
octo or whatever.
Octet. Alright, so if you're naming a substance, we'll do, oh, no, that's too easy one. We'll do that. Alright, so if you were to name it, how would you name it?
Carbon sulfate 2. Carbon disulfide.
Good job. So remember, you change the ending to I, and you put the prefix. Alright, let's do a weird one. Let's see. So you probably wouldn't see this in real life, but we'll just do it for now. Okay, so how would you do this one?
Dinitrogen trifluoride.
Good up.
Could you do nitrogen trifluoride?
Would it be what?
Could you just do nitrogen trifluoride?
How many nitrogens are there?
Nitrogen.
So, dinitrogen difluoride. Alright. Does anyone feel like they need to go over this again, or do they feel like they got it?
Got it.
Alright, go ahead and pick up one. Well, I guess since you two are so far apart, you don't need it. Make
Points.
sure you, what?
Points?
Oh, that's right. Anyone have 30 or more?
No problem with that.
42. Empirical formula is the simplest,
It's the simplest ratio.
and then what's the definition of compound formula? The chemical formula.
Chemical formula, it shows the relative atoms in a compound and the numbers for them. So saying like how many carbons are there, how many oxygens.
You said you had how many?
42. What is different? Do we don't need to know ionic?
Not there yet. So, so for like your homework, but it's too recent. So the
Molecular, what was it? Molecular
Okay.
compound?
A molecular compound is composed of molecules. Ionic compound is composed of ions. Molecular formula tells me if each type of atom are found in the molecule. A chemical formula is a symbolic representation that specifies the elements present and the relative numbers of atoms present. Alright, is that all your questions, or was there something else?
I think so.
Okay, I just wanna make sure we got the correct wording. Alright, go ahead and have out your pen.
I hate that.
It should be really straightforward. So look at those first couple of questions. It's just asking you just for the prefix. So it's saying, hey, what's the prefix for this type of substance? For naming these types of molecules. So all of these are about the binary ones. So just asking you, hey, deca means what? So just write off the number that deca means. Hepta means what? Nona means what? And so it's just going through, just asking just for that really fast. 5 through 10 is when it actually starts to get kind of tricky. So this is whenever it's asking you, hey, what is the name for this substance?
What is 6 through 8 asking again?
6 through 8 is asking it like in words, how would you name that? So don't write like into 04.
Oh, yeah,
it's asking you,
yeah.
oh, okay, how do I
Oh,
write
yeah.
this out? Like if you write out like in those, like with the actual names. Okay. Like what do you mean?
Like, does it want us to use prefixes?
Since this is a binary molecular molecule, yes, use your prefixes for it. Did you double check your answers? Because I don't want you to go too fast and accidentally make mistakes. Okay, I'm gonna sure. Anybody need more time?
Check it out.
Okay, just check your answers then. Jamie, Quentin, if you need more time, feel free to pause the video. Just make sure that you're going through it and getting through calmly what you need. You can go ahead and you got the textbook then, so we can start on the next section a little bit. We've gone over how to name ionic compounds, so I'll practice more probably tomorrow with them because I gotta move a little bit ahead for it. So turn over to page number in the textbook. looking over, do you feel better about life now? Okay, we can't talk about the quiz answers because Jamie and Quentin might not have finished yet. So, we'll talk more about it tomorrow. Alright, let's go ahead and let's look over on page 42, talking about how do we actually measure out chemicals in the lab and how to work with them. Alright, so your book starts talking about molecular mass on page 42. So if you're talking about a molecule, what's a molecule? Ethan.
That is the, something with two, I don't remember.
Okay, I'll take that. So it's two atoms or more put together for it. So molecular mass. Alright, what is mass? Alright, Chris.
How much of substance is in a certain area?
You don't, so how much matter is inside of a substance? Now, if we're working with mass, what unit do we pretty much always use?
Let's start with,
Okay, well, just like in general. What?
unit
What?
for mass.
For mass. Like just in general. Like for you, what do we use for mass? If we're talking about mass.
Weight.
Okay, weight is the force of gravity, but what are we measuring for mass? You're the one that's back in chapter 1, so it is kind of back there.
Liter, something like that.
That's volume. Alright, Chris? Remember?
For mass?
For mass.
Isn't it, let's start with,
Alright, so just in general for mass, you use grams.
okay, and
Grams.
then, yeah, you need kilograms.
Yeah, in kilograms. Now, if we're talking about atoms, can I use a gram for an atom? So what unit am I talking about? Mass?
Atomic mass unit.
Atomic mass units, or the AMUs.
Yep.
So that's what this is. So molecular mass is sum of all the atomic masses of all the atoms in the formula of a compound. All this is you're just looking to see what's the weight of this substance, what's the mass, that's it. Now, what's a handy dandy tool I can use to figure out what atomic mass is of any given element?
Spectrometer.
That's one way to figure it out, but you have a handy dandy tool in the back of your book to tell it for you. Periodic table. So if you look at the periodic table, I'm gonna. It's not unless you ripped it out. Yeah. All right. So if you look at the periodic table, I don't know, Jamie, if it shows up because it's kind of far away from the camera. But for this periodic table, and this is the same setup as the one in your book that it gives you. Here's the atomic symbol, and then it tells you the atomic number at the top. Remember, what's the atomic number? What does that mean, Ethan?
Means, atomic number,
Atomic number.
how much, how much proton?
Protons, because remember, can I have carbon and it have more than 6 protons? Can it have less than 6 protons?
Yes, no.
No, a carbon always has 6 protons. If I change up the number of protons, I don't have carbon anymore. So, for this periodic table, they put them at the very top center. I think in your book, they put it in like the top left. So, it's just slightly of a different arrangement. This is the idea of, okay, you have the atomic number at the top. In this periodic table, they have the labeling off to the side. I believe yours puts it directly underneath it to say, here's what this type of atom or element it is. If you look at the bottom, that's where they tell you the atomic mass for carbon. Scientists have already figured it out with the mass spectrometers, so you don't have to. So they know, okay, here's the weighted atomic average, because remember it's all the isotopes for carbon, we're talking about carbon. Collectively, for all the isotopes you found, the average atomic mass of them is 12.01. For oxygen, it's 16. For phosphorus, it's 30.97. So that is the weight of each individual in atomic mass units of each individual little element. But this is molecular mass. You're not just finding what's the mass of one individual element. You're looking to see what's the mass of the entire molecule. So it's basically pretty straightforward. What you do is you just take, okay, here's the mass of the one atom, here's the mass of the next atom, add them up together, here's the mass of the entire molecule. So you're just adding, basically. Alright, so let's look at this first one. So sodium chloride. Alright, sodium chloride, this is an ion, as a side note. So this also got to give us practice as well for it. So sodium, NaCl. Alright, so how many electrons does chlorine typically take? One. And how many does sodium typically give?
1.
So, do I need to do anything else in this, or is it done? Yay, so I'll give you practice for it. Alright, so find the molecular mass of the following compound. Alright, you're going to have to use your periodic table for this one, because we might start memorizing them, but you don't have to. So Jamie and Quentin, if I remember to slide it back over, so I don't forget awkwardly. that you can use periodic table for these type of calculations for it. So you're gonna have to actually, because there's no way to know these without using periodic table. Alright, what is the weight, or what is the atomic mass units of just sodium? You're gonna have to use periodic table to figure this one out. Alright, what's the atomic weight for sodium? Chris? I'm gonna walk, sorry Jimmy, when so sodium, Chris?
23.99.
Good job, so how many sodiums do I have?
Parents already in that.
What? One, so I just need 22.99. What'd you say, Ethan?
Where's that?
It's in column one.
Column one.
Yeah, that's what I said. You'll eventually memorize them.
Oh, and then,
Yeah.
I was looking for an X.
Oh. Sodium! So, 22.99. So, chlorine. What's the weight for chlorine, Ethan? That's in group 17.
Like what? 35.45.
Good job. So, 35.45. I'm gonna go and write the units on. So, how many chlorines do I have?
35.45.
Whoa, how many chlorines do I have?
One.
One. So, you literally just add them up together. So, 22.99 plus 35.45 becomes what?
That's all we had to do.
That's all you have to do. You're just literally figuring out just the weight of these things.
Eight.
I'm gonna say, alright,
58,
you have a calculator, don't do it in your head, but if you want to, you can.
$58.44.
Okay, well, this is atomic mass units, so
But
it's
okay.
units.
58.44 tons.
Good job. Alright, now for sig figs, do you go, now is this addition and subtraction? Do I go with the number of sig figs or do I go with the place? Place. So, how far out does this one go?
4.
How far out does this one go?
4.
How far, so this one, how far does this one go out?
4.
Does it have 4?
Yes.
Yay, done. That's it. That's the answer for this first one.
But-
So pretty straightforward.
Never mind. Yeah, 'cause sometimes you can have like 5 and then 4, right?
Yeah, now if it were to do this, if it were to do that, because this one ends
it
in the
would be
4th or the
5.
100th spot, it would still end in the 100th spot, because you go off the least accurate.
Oh, the least.
Yeah, least
Right.
accurate, because you don't want to make it seem like you did more work to remember more accurate than what you did. Okay, alright, let's look at the next one. So, dinitrogen pentoxide, this is a good practice one. So, dinitrogen pentoxide, how do you, what does that one look like?
Nitrogen 2. Oxygen 5.
Good enough. Alright, so going back to the periodic table, what's the weight of nitrogen? Alright, did you find it yet, Chris, or not yet? Alright, nitrogen is right next to oxygen, so it's right here in front of us. I'm about to say, you'll learn where they are, so it'll come with time, so don't worry about it.
14.01.
Alright, so 14.01. Alright, how many nitrogens do I have though?
2. So
Two.
times 2.
Yeah, so that's the easiest way. Now, you can type in 14 plus 14, sorry, 14.02 plus 14.02. That works, but it's easier just to do it this way. Alright, and then oxygen weighs how much, Chris?
122.
Wait, oxygen weighs how much?
16.
Yeah. Alright, so 16. How many oxygens do I have? 5. So it's 5 times 16 plus 2 times the 14.01. Alright, what was your answer?
122.02.
Not quite. So just double check it.
108.02.
There you go. So 108.02. What's your unit? Good job. So does U or AMU. Alright, so looking at this one now. Alright, so sig figs, you go with place or do you go with number?
Please.
Place. So where does this one end?
4. 2.
Okay, so how far out does it go? To the tens or the hundredths? Because you go up the place, not the hundredths. How far out does this one go?
One's place.
Here?
Yeah.
Why do these not count?
Because there's nothing blocking the lane.
Alright, now, if they're to the right,
Because you can just get rid of them and it'd be the same exact amount.
but if there is a decimal point, the scientist is saying, I've measured it out this far on
But
purpose.
it doesn't matter because it's just 0.0000.
But there's 4 though.
Yeah, but the scientist is saying, I've measured it out exactly. I know this is exactly 16 AMU. I checked it too. The 100, I checked the tenths and the hundredths. That's what the decimal point is saying. If he just said 16, he said, no, it's about 16, not sure.
So
Could
give
be
us a 14.
16.1, could be 16.2, not sure exactly. Could be 16.4, not sure.
Alright, so it's 108.00 is the units.
So, just saying for this one, okay, so where does the sig figs end at for this one?
4.
Yep, so there's 4 here, so it ends here as well. So where does it need to end in your answer?
The 0,
Why?
because there's 4 units there.
Okay, no, you're going off number.
Four.
So place.
It's then 0 is 4th place.
Okay, no, this one goes to the
Oh.
100th place.
So it's right, it's 108.00.
Yes, I'm just making sure you're thinking it through, cause sometimes it trips up students because they want to round off to the 4 spot. That's why I'm saying, do you go to the place, like 1s, 10th, 100th, or do you go off the number? There's 4 sig figs, 4 sig figs, 5 sig figs. Sometimes it throws off students. That's how come we're checking to make sure for sig figs that you know what you're doing. So even though there's 5 sig figs down here, because it ends at the 100th spot, it's still correct and it's still right.
That confused me more.
But you gotta know it, because if you change your answer on the test and you mark it, I'm taking off points for it. So you have to get practice. That's the reason why we're checking to make sure. So you gotta learn it. So I'm sorry it was confusing, but you have to learn it. Alright, let's look at the next one. Carbon dioxide. Alright, Chris, what's this one? What is the formula for this? So carbon dioxide.
O2.
Good job. Alright, so what is the weight of carbon? Ethan.
12.01.
Alright, how many carbons do I have?
1.
1. Alright, oxygen is still 16. You're gonna really memorize that one.
32.00.
44.01.
Sorry, what was that?
44.01.
So it's 2 times 16, which is 32, and then plus the 12.01. So 44.01. Alright, why is there 4 sig figs down here, or why does it go to the 100th spot?
Because there's a 100 spot and then the answers to both of them.
Yes, so because of that, it has to go to the 100th spot as well, because addition and
So if
subtraction.
it was like for subtracting or multiplying, would it be like how many there is?
Alright, for multiplication and division,
That's what I
that's what it is, unless it's off numbers. So sometimes it throws off students because addition and subtraction are kind of weird. But yeah, and we don't work with addition and subtraction that much in chemistry. Most of the time it's division and multiplication, so that's what we always have to check to make sure
That's by place, and the other ones are what?
it's by number. Like if you're
Number.
doing multiplication
Okay, I
division,
get it.
it's number. Okay. Anyone have any questions about how to find molecular mass? It's pretty straightforward once you got it. Anyone have any questions about this? Alright, so Avogadro's number. So scientist Avogadro, he technically didn't figure this out. He was working with gases, and he started noticing that based on the ideal gases and the gas laws, that the same volumes were starting to relate to each other. Scientists later on figured out, that if you have an Avogadro's number of something, then we have the same amount over and over and over again. So technically Avogadro did not discover this. A lot of people assume it, but he did it. Avogadro's number, mark this at the top of page 43, you can memorize this number. 6.022 times 10 to the 23rd, you must memorize that one. So 6.022 times 10 to the 23rd. Alright, if it's 10 to the positive 23rd, is that a very large number or a very small number? Chris?
Extremely large.
It's very, 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 very large. This one is huge. So, your book just pointed out that this number is extremely large. Now, we're talking about atoms in a substance. Now, the definition of it, your book points out, it says the number of atoms in exactly 12 grams of carbon-12. And since the atomic mass unit is also based off the definition of carbon-12 atomic mass, that's how come these two ideas relate together. Your book's trying to give you a very simple explanation. It's much more complicated than that, so just take it as, this is Avogadro's number. If you have 12 grams, measured out 12 grams of carbon-12, you're gonna have that many individual little bitty atoms of carbon sitting on your scale. So Avogadro's number is a number saying how many of the atoms that you have. Scientists have figured out since then that, okay, if you have the mass and weight of the atomic mass units of a substance, you're going to have the same number of particles on the inside of it. So that's what it's trying to say in that italicized portion. A mass in grams numerically equal to the atomic or molecular mass in atomic mass units will contain Avogadro's number of atoms or molecules. So what they're saying that if I measure out 12 grams in the laboratory of carbon, then I will contain exactly Avogadro's number of atoms on the inside. I'm going to have that really large number sitting there on my petri dish. If I were to measure out 16 grams of oxygen, because oxygen weight, 16 atomic mass units, if I measure out 16 grams in the lab, I'm gonna have 6.022 times 10 to the 23rd individual little oxygen atoms sitting on the petri dish. If I were to measure out for carbon dioxide, since carbon dioxide has the molecular mass of 44.01, then if I were to measure this out in grams, I would have Avogadro's number of carbon dioxide little molecules. If I were to measure out 108.02 grams of dinitrogen heptaoxide, I would have this number of atoms or molecules technically sitting there. So scientists have figured out that if you measure out the atomic mass units, if you get the same number sitting there measured in grams, you're going to have this number of atoms, individual little atoms there as well. So this is what scientists use to be able to actually work with atoms in the laboratory. Because if you work with something like this, now this is not balanced, we're going to ignore it for right now. But for this substance, can I work with one individual atom of hydrogen at a time? Not really. Can I work with one individual oxygen atom at a time? Not really. So even though we write it out like this, and technically it's not balanced, I'm going to ignore that for right now. Scientists know that, okay, I can't work with this. I have to work with grams. I can't see one individual atom, and I can't work with one individual atom. It's not going to work. So I have to be able to actually measure this. So Avogadro's number allows us to figure out how much do I need in order to get the same ratio for a substance. So if I needed, like for example, one molecule weight, or if I needed one substance of dihydrogen, I can't measure out one individual one. But I can measure out Avogadro's number, because Avogadro's number tells me that if I get the weight of the dihydrogen in grams, I'm going to have this many individual little atoms on the inside of it. We have a unit to kind of simplify that. Instead of saying Avogadro's number over and over again, we just use the unit mole. So go ahead and mark that on page 43. A mole, or abbreviated just MOL, because scientists are lazy and they want to drop the E, is Avogadro's number of anything. So instead of saying I have one Avogadro's number of something, we just say I have 1 mole of something. Kind of like saying I have a dozen donuts. If I have a dozen donuts, how many donuts do I have? 13. A dozen?
11.
Hurt my soul.
699.
Okay, for real, how many do I have? Yes, so 12. So it's the idea of, okay, if I have a dozen, I have 12. So for a mole, if you have Avogadro's number of something, or if you have 1 mole, you have this amount of atoms. So it's just sometimes to say it faster. Alright, I'm just about out of time. We'll start more. We'll practice with this tomorrow because it can get a little bit confusing. Alright, you don't have any homework because it's Wednesday. And make sure you're still looking over it.
Isn't there a visitation today?
Not today. Pastor Adam said not quite yet because we're trying to finish at the gym, I think.
All the time I heard that we were doing visitation, and then there weren't set aside visitation.
I texted him yesterday. Alright, so thinking back over it, what do you call the sum of all the atomic masses of all the atoms in the formula of a compound? Okay, atomic mass unit is an individual atom. So if you're talking about the molecule,
What was the question?
what is the sum of all the atomic masses of all the atoms in the formula of a compound? M, technically.
Molecular compound.
Okay, molecular, you're talking about all of the weight.
Molecular compound.
You're talking about all the weight altogether.
Molecular mass.
Molecular mass. So that's the sum of all the atoms' weight all together on the inside of the molecule. What is Avogadro's number? What is that number?
6.022 times 10 to the 23rd.
You're gonna have to memorize it. So just memorize that number. You have to. Have to. Alright. What is, ooh, I forgot to go over the chart. Memorize. So, do you make a note of the chart? We're gonna have the quiz on, I think I said yesterday, next Tuesday, so make sure you're
Wednesday.
studying. Did I say Wednesday?
Mhm.
Okay, it's Wednesday. So make a note that you're studying these. So, this would be what?